Button accepted.
All right, it seems that it's time to start this presentation. People, since there are still people rushing into the room, maybe let's postpone it with a few moments and let me tell you a bad joke I've just read. So a recruiter tells to a developer, "If you tell me about deadlocks, I will hire you." And the developer says, "If you'll hire me, I'll tell you about deadlocks." Yeah. One of these bad jokes which can be told events like this one, because we understand such nerdy jokes. There are still seats in the front, so please don't hesitate to take one, really. Since this is going to be a deep dive, we're going to talk about Java, or I should say enjoy the newest releases of Java for 2 hours, so it might be tiring just to sit or, I don't know, take a place next to a wall. So make yourself comfortable. All right, so the topic for today is Java 17 and 18, what's new and noteworthy. I'm really glad that the deep dive formula went back or came back to Devoxx Poland, like pretty much every other Devoxx. My name is Piotr Przybył, and here I'm lucky I don't have to explain to you how to pronounce it. We're Devoxx Poland, right? So briefly about me, this is my social media handle. If you'd like to ping me or, I don't know, ask more questions or something like this. I've been working for years at a position or as a role called Software Gardener. If you don't know who Software Gardener is, then you should read a book, fantastic book called Pragmatic Programmer. There's been a second release, 2 years ago, something like this. I also work as a trainer from time to time. I work, on a daily basis, I work at a fantastic startup called Atomic Jar. So we are about test containers and beyond. And also every now and then, unfortunately not frequently enough, post some stuff on my webpage, softwaregarden.dev. This is basically me, right? So for years, basically, even before I graduated, I started working with Java or using JDK, then some Scala and such stuff happened to me. So even when I go on holiday, Java is still somewhere in my background, right? So this is what happens to me. And the question is, who are you? Who is the JDK developer, primarily? Raise your hand. Don't be shy. So what are the others doing? Like, are you guys like testers, Python, .NET? Testers. Okay, you just want to. So you want to know what's like new in Java because. Okay, because Selenium and automated test. Okay, any other languages than Java, like Scala, Kotlin? Quite a few hands. Some Groovy still, perhaps, or Clojure? No Clojure people. Okay, right. So who's using Java 17? Java 18? Come on, I don't see a single hand. Why is that? Okay, you're perfect room then. Who's using Java 11? I'd say half the room. Who's using something older than Java 11? Okay, unfortunate, I would say quite a few of us. All right, so now we are who we are, right? And now we know who we are. All right, before we actually start, a safe harbor statement, caveat auditores, everyone can make mistake, including myself, right? Don't trust talking heads on the internet, especially if people are excited about it, because then it's like not just information, right? Or no news, but it's propaganda, basically, right? So, erae humanum est. Java 17. Java 17 is a long-term support version by the majority of the vendors, if not all of them, as far as I can tell. So it was released in mid-September last year. It had 14 JEPs in total, Java enhancement processes or proposals, sorry. Here's the link to release notes. There's new syntax being sealed classes. There are preview features like pattern matching for switch, for example. There are incubator modules like foreign function and memory API and vector API. And there are new ports, especially the Mac owners should be happy. Folks, that if you'd like to see, there are still some seats available here in the front. And of course, there are other features, right? And this is the first 7 JEPs of Java 17, and this is the second half of the JEPs, right? Java 18 came as expected half a year later in March, right? So it had less JEPs, like 9, but I wouldn't say only 9 or just 9. It simply had 9 JEPs, right? Again, release notes for you. No new syntax as far as I can tell. There are still preview features like pattern matching for switch, again, like a second preview. There are still the same incubator modules. And for example, finalization got deprecated for removal. That's like from the most important deprecated changes, I would say. And there are also other features, right? So this is the whole list of the JEPs of Java 18. I would say thank you, enjoy your afternoon, right? No, of course, that was a bit of trolling. All right, so we just saw the voting that happened here like 2 minutes ago, right? So apparently, you or your team members or whoever is keeping this big pile of gold is asking the question, shall I migrate or shall we migrate to Java 18 or stick to the latest LTS, right? Being Java 17 in this particular moment. So the answer is, it depends, right? If your software runs on Java 18, why not? I mean, this should be the primary paradigm or the primary the primary way of working with Java these days. And by these days, I mean like last 3, 4, 5 years, right? So you basically keep updating your Java every half a year. That's the way it should be. I mean, by the definition, by the default. And I'm really surprised that Java 18 came like 3 months ago and nobody's using it, all right? So this is what you should be doing. You should like rely on LTS for, I don't know, like certification reasons or like, I don't know, like it was approved by some, I don't know, super important people, I don't know, some demons from deep hell or whatever, right? In such case, you should, unfortunately, because you have no other choice, you have rely on like LTS, right? Because LTS, what's actually the LTS? LTS has nothing to do with the technical stuff, with the quality of the release or anything like that. It's just a business term, basically. It means that if you go and pay someone money, they will support the version tagged as LTS for longer than any other version. And that's just it. There's nothing more behind that, right? So there is no, I don't know, no more that LTSs are more reliable or more tested or I don't know, anything. In technical way, they are no better than any other version, right? That's why you should stick to the latest. Maybe you should skip like using preview features in production, especially if you're not using like microservices or something like this, right? So microservices are easy to rewrite. So of course you can experiment because if, I don't know, there is like a preview feature gets like unmerged or something, there is no big worry, right? But else, especially if you're shipping stuff for your clients or customers and they're running this on premises, then of course you should rather restrain from using preview features, although we use them sometimes. Yeah, and as I said, non-LTS doesn't mean banana soft or monkey soft, right? It's a good piece of software, a good piece of engineering, right? And you should be using by default the latest one unless there is a reason for you not to do that, right? So this is the mindset you should have after you leave this room, folks. There might be a change in the LTS cadence, meaning when Oracle announced that they will release for their own Oracle version, right? Or Oracle JDK LTS, this will happen every 3 years / every 6 releases, right? It seems that there might be a change I'm like kind of like not sure if it's like already committed or not, but it might be that we will have LTSs every 2 years / every 4 releases, right? So instead of Java 23, we might have Java 21 as an LTS, right? For Oracle, for other vendors, this might be a different policy. There are other vendors supporting like some other versions for longer than the usual or required 6 months, right? So Azul is the first coming to my mind. So as you can see, LTS is a business term, business contract, right? Construct. Okay, so let's now switch to the actual changes. So what happened in latest releases of Java? So sealed classes is something that happened as a standard feature to Java 17. As a JEP 409, these should be clickable links, so if you're interested in going and reading about details of like sealed classes or any other changes, you should be able to do that from the slides. So the concept of sealed classes is known in other languages, also in other JDK languages, or JVM languages like Scala, for example, right? And in Java, they are implemented slightly different. So when they are used for is, for example, in a situation when you maintain a code and somebody else is using this code, and you're not the ultimate or the very final user of this code, right? So, for example, you're a library maintainer, like a free open source library, or like inside a company, you work on a team that's, I don't know, creating an artifact that is used by several other teams, for example, right? This is also like a common pattern. So, in such a situation, it might happen that you want that other people to extend your classes or implement the interfaces you have in your code, right? And for some reason, you don't want to use final, or you can't use final, right? Because, for example, like dynamic proxies, or you want to, I don't know, whatever. So you can't use final, or you don't want to use final. And you also don't or can't reduce the visibility from public. For example, your tests are existing in other package, right? Therefore, you want this class to be testable, you want it to be public, right? So it can be public, it can be final, and yet you want to enforce that nobody else is able to extend this class or implement this interface. So this is where sealed classes come handy, right? So they are meant, in my opinion at least, to prevent bad and unintended code reuse by inheritance. Right, so there's nothing wrong in inheritance as such, right? In object-oriented programming, inheritance is like a valid mechanism, right? It's needed to express like the type hierarchy and whatnot. The problem is, right, that people start using inheritance to reuse the code where they should be using composition. That's the problem, right? And you want to prevent that / enforce that using sealed classes and not some other third-party tools, I don't know, like ArcUnit or whatever, right? So this is how it works. You have this class, like the class name, and you just toss sealed in front of the name of the class. And then you can follow with permits, right, and then an enumerative list of the classes that are able to extend it, or interfaces, right? If that's an interface, because it doesn't have, I mean, I will keep saying sealed classes, but it also applies to interfaces, right? So I would just won't say interfaces and classes, it's just classes, but it applies to both. Okay, so then this child can also be sealed and permit its own descendants, like think grandchildren or something if it was a family, right? And of course, the second child can be final. Final is basically like sealed with empty permits. I mean, such construct is not possible unless something, so you can say final. And the third option, you can say non-sealed. Right, and it has this dash. So if you have regexes parsing something, you have to, like Java files, you have to update this regexes. And this non-sealed means for this child and its descendants, I want to opt out from the sealing mechanism, right? I don't care who's going to implement / inherit this child 3. And if all these classes are in the same source file, the permits list can be implicit, meaning you don't have to type it verbosely. It's just needed if these are in a different, in a separate files, like when they are public classes. But if they are not public, it's okay in the same source file. Then you can omit the permits clause, right? And who's using modules in Java? One hand, second hand, third hand, fourth. 5, 6, 7, okay, 7 people. So we can use sealed classes in any package, right? Whatever we please. For the rest, everybody else, you have to keep them in the same package, right? This is how it works. So sealing without modules works only in the same package. And this is just a little code to illustrate a possible use case for this feature. As I said, it's very handy for like library maintainers or something like this. So this, my friends, is like back in the day when I was in university, we used to call it UML, right? So it's like a diagram, and if you don't understand what that is, I will just explain you in no time, no worries. So this is the scope of the library, more or less, and this is the scope of the user code, right? That's somebody who's using our library. And we have this precious library type, let's say a kind of like super fancy another logger, because, I don't know, we have a dozen of logging libraries in Java, and still you have to implement another one because reasons. And then, whoa. And then you have two classes implementing this interface, and then you have two classes descending from this class, right? So these green rectangles, triangles, basically mean that this is your own code. You permit this inheritance is okay, right? And then from the user code, we allow the blue lines. Like, see, this is like a usage, and this is like the composition. So if this some class can use our library type, for example, a parameter type or return type, or as a field type in this very case, and it's okay. Like this, it can be used if visible, of course. So if it's like there are no other constraints, right? So if it's not private and whatnot. And what we don't want to permit is that this inheritance, right? So we don't want our users or the users of our code to extend from this class or implement this interface. That's why this is in red, right? So cannot extend or implement because not permitted. And in the code, it would look like this. Maybe I will switch to the IDE. And the question is, oh, this is unstable version, unfortunately. Okay, so sealing. Where are we? Sorry. Yeah, library type. Yeah, that was this, or wasn't it? Yeah, that was it. Okay. Right. So you folks can see the code. Okay. I guess it's pretty readable. Okay. We have this sealed interface, right? Library type. We're not just translating this UML, right? And it permits this abstract lib type implementation and this no implementation, basically. And as you can see, even IntelliJ like tosses some like extra things to make it easier to work with. We have this abstract class, which is sealed again, and it also permits its own descendants, right? And we have this class is final, and this class is final, so it doesn't need any like permits or anything, right? And so this is it, basically. And because it's in the same source file, I can basically omit this. See, and it still works, it still compiles, there is no issue because it's in the same source file. If it was in like scattered to different source files, I would have needed this permits clause. Right, and then we have this user library type implementation. Normally that would be like, somebody else's repository and whatnot, but could be also ours for this little demo. And see, neither of this works because, do we have a hint? Yes. User lib type implementation is not allowed in the sealed hierarchy, right? So basically, it's not when we have this type, right? So this type doesn't permit this user lib type implementation, or this library type also doesn't permit the same thing. That's why it's forbidden, and it's nice because now it's blocked by the compiler, right? No like ArcUnit or third-party tools or whatever, I don't know, style checking you have. Therefore, the feedback is much, much faster, right? But people still can use this pretty much like every other class or object when they are not using, /abusing the inheritance, right? So see, it's perfectly fine to have this as a file type, right? Field type, or have it as a parameter type. It works. It keeps working. There's no change here. And just to demonstrate you a bit more, as you can see here, I have also two modules. The code is on the internet. You can clone it and play with it if you wish. We have this sealed unnamed, which is unnamed module. And if we go here, you can see like examples of more sophisticated structures. For example, if you have like various domain events and you want to model that, right? So, for example, we have this event. Let me just generate a diagram for you. Hopefully we'll see that Java class diagram. Yeah, so this is okay. It doesn't show the names in the presentation mode, but you can trust me that these are these types, and this is like the whole hierarchy and whatnot. And if this is like, for example, the types you like mapped into your database or an ORM or something like this, and you don't want anybody else to go, for example, and have this non-sealed, this quota exceeded event, for example, extending hosting events. See, then it won't work because it's not permitted and because the permission doesn't come from your library, right? So even if you do that without modules, it will work nicely. And if you happen to have modules, and that might be, I mean, sometimes there's like a benefit, like a huge benefit from doing that. See, I have this module-info Java file, which is a module descriptor. Then I can basically scatter these all these events through different packages. They will end up in the same module, in the same jar file eventually, so it's okay, right? So this is how it works. If you have any questions, just raise your hand or signal any other way. If you're looking for a free seat, we still have a few seats here, so over there. So there is no reason to, like, I don't know, unless it's a leg day for you guys, so no worries. Yeah. So in my opinion, or in my reading, now we have 3 ETs in Java which are overlapping, but they are not exactly the same. And we have the visibility, right? And we had the visibility since the day 0 of Java, basically. So this is the public, private, protected, right? This is the stuff. So if you can't see a type, if you can't see a class or interface, obviously you can't use it, right? So this is the visibility. But then with Java 9 and the project Jigsaw, or Java Platform Module System, we have modules. And they define accessibility. So even if a class is public, but it's not exported, you might not be able to access it in your code. So it's something different than visibility, right? So of course, you won't be able to access like private types, but now you might not be able to access also public types if they are not exported. And here, with the sealed classes, or previously with final, came the extensibility, meaning that you might be able to see the type, it's visible to you, it's accessible, but it's not extendable, right? And previously we had this nuke option, so it was either final or not, and we can now fine-tune this with this sealed classes. So you can, in a way, think about this final like it's like a cherry picking for whom it's final, for whom it's not, basically, right? And of course, there's been no change to the final mechanism. It still works as it was working for decades, I can say. Okay. Question.
I just wanted to say that there was one more mechanism which is maybe not well known. Like you could sign the jar, for example.
Yes, there was. So the remark is there is one more mechanism signing the jar and security manager and stuff like this. Yes, and the applets. We'll reach that point later. But thanks for the remark. I should have something for you. I throw, you catch. Okay. Great. Not exception, but yeah, still caught. Okay. So strongly encapsulate JDK internals. Which is a standard feature and introduced in Java 17 as JEP 403. So, as I told you, or as we know, Java 9 brought us the warnings about illegal access, right? Because it introduced the modules, and perhaps you've seen something like this. Let me show you that. So let's go for 17. And it should be strong encapsulate, and terminal was, something like this. Yeah, exactly. See, I have something like this already prepared. So we saw something like this. We tried to run a code, and we saw that an illegal reflective access operation has occurred, and blah, 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 yada, yada, yada. Yeah? So this was this warning about illegal access, right? And some people suggested that these are just warnings, right? Don't read them, don't worry, don't bother, ignore, right? We care about errors, we ignore warnings, right? And whereas some people followed this advice, right? And kept producing code the same way for a few more years. So, I don't know, I mean, this is the problem. If you follow this advice and totally ignore this warning, probably you haven't read this thing, which says, all illegal access operations will be denied in a future release. Right? So it was promised to be temporary, basically. So then Java 16 happened, as we all know. And in Java 16, it works a bit different. So when we go something like this, when we try to call it the same way, suddenly the code doesn't work, right? Because of the illegal access, because of some problem with like internals of the code. So what the same people said again, I mean, now we can't ignore this because this is an error, like it doesn't compile, it doesn't like run, so what's the problem? I mean, what do we do, basically, right? So what they suggested is that you go over here, just at the very beginning, all right, and you just go -- illegal access equals permit. And voila, the thing is working, right? So we gained our warning again, we can ignore it happily again, and time for a counter-strike, right? Not quite, I would say, because what they didn't read is this thing. It's a new part of this warning. Like option, illegal access is deprecated and will be removed in a future release. And this was Java 16, right? So what happened in Java 17 is just, let me try to copy the same call. Let's copy and let's paste it. Unrecognized option, sorry, it didn't copy properly. Yeah, sorry, there was 2 lines. Java illegal access. I hope I didn't make a typo. Yeah, see? And it now says illegal access permit support was removed in Java 17.
Is there another flag to bring back the support of that flag?
The question was, is there another flag to bring support of this flag? Germans have a perfect answer for this, and the answer is jein. So yes and no at the same time. And I'm really glad you asked this question. Let's draw something for you. This thing. All right. So what you should do, first of all, I mean, the very first, or the actual problem is that we are trying in this code to use / abuse reflection, right? And I just can't keep showing this thread enough. So I will show you this. This is a video posted by Sergey Yegorov a few years ago, right? And I loved it. And I encourage you to see this. So this is what happens when some people use Java reflection to overcome some limitations of your stupid library, right? The library doesn't work. How come? Let's fix it with reflection. Yummy, right? Right? So if you misuse reflection, this is what happens, basically. Please, so reflection maybe not necessarily was meant for that. So the evil is in this very line. So value field set accessible true, right? So we are opening the gates to the hell to call or to summon the demons of deep reflection, right? Because it's nothing bad about reading using reflection, the list of the public fields, for example, of public methods. That's okay. But if you want to try to use the reflection to open, right, to violate the encapsulation, then demons come, right, and enjoy their presence here in this universe, so we shouldn't be doing that, basically, right? So what we should do, we shouldn't use any flag, right? We should fix the damn code. Right, so let's do that. So instead of having like, because what we do here, we try to look into this byte array, so maybe let's do something like this. Let's go value, input in our case, that was input dot get bytes in standard unit, and we used to print this out, so let's copy that here, and put it like, I believe, here, right? Should that be byte array? Yeah, so we don't need this, basically. See, then we suddenly don't need to catch anything because nothing is going to blow, and this is it. So how many seconds are there in the in an instant? So let's do that again. So let's go for now, get epoch seconds, okay, and we're gonna print this out in here instead using deep reflection, so we can get rid of this, so we can stop pouring about the exceptions, okay. And let's see, oops, too much. Right, and let's go and see if that works again now without the illegal access flag or switch or whatever we call it. It works, see? This is how you deal with warnings. You fix your code. You just stop tossing more and more flags, right? However, I know life is not so beautiful. Sometimes you don't own the code. Sometimes you don't even see the code. So sometimes you have to do something. So what shall we do then? Then, my friends, I suggest you go back to Java 16. You use illegal access with like warning, for example, and then it will show you the list with stack traces of all places where the illegal access takes place. And then you use this list. Let me bring this back to a state where it was, right? So we're rolling back our fix. And basically what we can do is we can say like toss this add opens. So we can say, okay, yeah, I know this is summoning demons, but now I will like, I don't know, code that, or I will tell you that I am aware of this. So it is kind of like a blessing, right? In this way. So we say add opens, and we say from the Java module, open the Java lang package where string lives for everything that's all unnamed, meaning my whole class path. And I will also add open the Java base, same module, right? And I will open the Java time package again for everything that lives in the class path. And when I call this, it should also work. Let's try with Java 16, paste. See, it works again, right? So this is another flag you asked about. Right? So if you can't fix the code, you have to compile the list of these add opens. Right? But I would say this is not the best solution to the problem, right? So instead of blessing the demons or whitewashing the demons, it's better to get rid of the demons, right? Right. So in Java 17, as you just seen, thanks to JEP 403, and I don't know, is that an Easter egg or not? I mean, we all know what 403 means, right? In HTTP response codes. So I think it's a perfect code name for this JEP, like access denied. No more, nada. Illegal access is no more. Yeah. I personally enjoy it. Okay, so what to do, just as I have shown you, first stop using set accessible true, get rid of that call from your code base, right? Then if you can't do that, then just switch to debug or warn for legal access in any Java pre-17 version, right? And start adding these add options. And as a last resort, just don't upgrade past Java 16 and keep producing legacy code for future generations, because that's the other way. You can do that. All right. So I even wrote a poem about this. Roses are red, reflection may hit. You shall not use illegal access permit. All right. The only poem I wrote in my life. Thank you very much. Yeah. More about it on my blog post. Right. Or if you like more about tuning this, I was talking about this like on Devoxx. I know, like 4 years ago, I believe. How to tackle this illegal access deny issue, right? So there's a link to the video, like a longer section. Okay, another thing that happened. Who's using Windows? Okay, you guys will be interested. All right, because this thing I'm not sure if there are any Unix/Linux users that will be affected by this, and I'm pretty certain that Mac users, unless they're using something very old, will be affected by this. So it might be like affecting people using Windows, okay? So what is the thing? Now UTF-8 is used by default, but where? Like it's a standard feature, JEP 400, right? So there was kind of like discrepancy in Java, okay? So all this new I/O, or native I/O, stuff was already using UTF character set as a default. But all the old stuff, like printers, writers, and readers from Java I/O used the native encoding from your operating system. Meaning the same code on Windows was producing a file with different encoding than on Linux or Mac, right? Unless you have, of course, specified explicitly the character set, which should be the case. But in case you've forgotten, then they like fall back to the one dictated by the operating system or like inferred from the operating system you're using, basically, right? So when it wasn't specified. Yeah, and now we are able to set this file encoding option, but not when the program already started, but before we call this Java process or start this Java process, right? We can even set the compat or UTF-8. UTF-8 is by the default, and if you want to bring the old behavior because there are, I don't know, the dragons skipping the gold pile tell you not to touch the code, for example, right? Ideally, again, you should go back, fix the then code, make sure it's UTF compatible and whatnot. But if you can't, you just go for the compat stuff, right? And this was like, I believe, from Java 5 or 1.5, whatever we call it, that there was this call for the default character set. And now, because it's like since Java 18, it's not easy to say if the default is the UTF or the platform dependent. Now it throws the exception. So if you have a call like this in Java 18, it's guaranteed to throw you an exception, right? And if you have source files not in UTF-8, then of course you have to compile them using the encoding. I haven't seen source files for Java not in UTF for like 12 or 13 years, but it might be there's still like this old, I don't know, SVN repository keeping that in, I don't know, like Eastern European encoding or something like this, right? So I'm not going, I'm not going to risk like, I mean, let's keep the demo gods happy, and I don't want to run Windows, right? Even in virtual machine here, I mean, let's stick to Linux, but there should be, come on, let's make it bigger. If you're interested, if it works for your machine, for example, you should run this demo on your machine or the environment when you're running your stuff. And as you can see, this produces different results in different encoding, basically, because this is like my native OS native encoding, and this of course doesn't work in the terminal because it's Windows 1250. Yeah, and we have a new flag now, or a new system parameter. Yeah, so if you're not able to use the UTF, also use explicit character set. But we have a new thing, and the thing is, so I should have it here. Native encoding. So, ideally, before upgrading to Java 18, if you suspect you might have a problem with that, right, dear Windows users, just run this piece of code, and if you have native encoding different than file encoding, than UTF-8, right, it means that most probably you have to take an action. Basically, you have to check if your software behaves correctly, if every if every printer, writer, and whatnot is using explicit character set, because if it does, then you're safe. And in case if you're not set, you can switch back to this compat, or ideally you can go and switch, even like for Windows encoding, but set explicit encoding for every printer, writer, and whatnot, right? Everything from Java.io, basically. So this is like the purpose of the native encoding of this property. That's why we have printed it here. Okay, time's running. So deprecate finalization for removal, another standard feature of Java 18, as this JEP 421. So now the finalize method is deprecated for removal, meaning it's not just said that you shall not use it, it's just said that it will be removed in the future, right? And as we know from the illegal access, removed in the future release means that it might be eventually removed, right? So it's like no joke about that. Or like now it's like a big warning if you're still relying on the finalize thing. So again, we should have a demo for that. Come on, this presentation go mode. And finalizers, yes, finalizers, okay. So, now when you compile a code, the compiler will issue warnings that you are using finalize in your code, right? Declaring this method. Or when you run such code, it will the Java file recorder will record an event, right? That such a method like was existing and was called and whatnot. So even if you don't own the code, you can still check it if it's still if this method is still used. Right? And you can simulate what will happen with in the future version when it's eventually removed by this finalization disabled flag. So just to check if your code will behave exactly the same, because maybe you're relying on a finalized method in a way you shouldn't be for years, actually. And the future versions might need finalization enabled in case you really need more time and you depend on that method. And finally, the finalized method might be removed altogether. All right, so meaning if you still have it in your code, the code won't compile, basically. Right, so let me just quickly demo what is it all about, right? So we have this, don't do that. Don't do that at home, don't do that at work, just don't do that. It's demo only, okay? Demo only. Maybe I should demo only. Please don't do, because this is this gets recorded and then somebody calls me after 3 years, but this is what you do during the presentation, right? Okay, I don't, just this is demo. All right, so what do? We have this object and we have consuming some memory basically, and this is only for debug for the purpose of this demo. And what we do, what we see here, we have this finalize method. Do you see? It's there's a strike through, right? Red strike through meaning deprecated for removal. In this finalize, and we call super finalize, and we say called finalize on this thingy and whatnot. And yeah, and this is what we basically do. And now let me just make sure everything is more or less as it should be, and let's see if this thing runs. Okay. Oh, out of memory error. How come? How is this possible that this code just stopped so quickly? Any answers? It's a very good direction. Any other answer? Basically, this program, this simple snippet, is a naive approach, but it proves the point, right? When I have a memory limit quite low, low, for some it's big, right?
Your finalization queue is being executed slower than the new object.
Exactly. So finalizing and clearing, I throw you catch, okay? Perfect. So we are creating new objects faster than we are able to garbage collect the old ones. Basically, that's why we get out of memory error, despite not keeping reference to this object anywhere. As you can see, it's not assigned, right? So as you can see, there's a number of problems with finalize, okay? We don't know the latency. We don't know where it will be called, okay? We don't know which thread it will call it, okay? There is no time cap for the finalize method, right? So it's aborted what takes too long, okay? It can do even nastier things, like it can resurrect some objects, or it can create more objects in the heap. Basically, this is Pandora box, right? It seemed to be a nice solution 25, 27 years ago, but now we all realized and reached the point that finalize is not the mechanism to release some resources, because the idea was like this. The object, when we have object in Java, may not only represent the memory on a heap, but also some other resources, I don't know, an open connection to the database, an open file descriptor, just you name it, right? An off-heap memory. And the purpose of the finalize was basically to clean after this. But because it's actually not deterministic, then we can't guarantee literally anything about it. And let's try to run it again to prove what I mean. See, these numbers aren't consecutive. How come if we see we have like atomic long here, right? So it's guaranteed to be like, you know, in series and whatnot. And as you can see, these objects are garbage collected like, okay, more or less in the order, but it's not the exact order. So we know nothing about the finalize. So that's why we should be using this, right? Instead, we should be using, for example, try with resources since Java 7, basically, right? So this is it. So it says that finalize is not okay, and how to simulate how it will work in the future. Basically, we go, sorry, no, don't try to run again. But where do we do that now? And that should be the JVM options, I guess. Yeah, we toss finalization disabled, right? So we're now back to the future. And now, as you can see, this program keeps working, right? It doesn't call the finalize method at all. That's why we don't see this. What it does instead, it says that it reached every 10,000 object that it reached this milestone, right? As you can see, it keeps working and keeps working and keeps working. So we have some resources to be released. You should depend on try with resources, on auto-closable, on closable, and whatnot, right? This is the message that comes from this JEP, basically. Okay, stop. See, it kept working, no issues. Alrighty, simple web server. Standard feature in Java 18, as JEP 405. Just without checking, you know, without Googling from the pocket, what's the 408 code stand for? Any guesses, any answers? Sorry? I just can't hear that. No, it's not I'm a teapot, sorry. It's a proper answer. Okay, whoever like Googles the answers first will get the jellies. Okay, sorry? No conflict. This is not a parliament, come on. Okay, I will... Sorry? You sure about that? Request, who said request timeout? Okay, you got jellies. Yeah, it's request timeout. Almost. Okay, yeah. Jokes aside, simple web server. So previously, sometimes there's a need that you desperately need this very simple web server just to, I don't know, statically host some files. And that's pretty much it. I mean, no rocket science, and you need that just for, I don't know, debugging purposes or testing purposes or for, I don't know, a quick demo or whatever, right? And then this simple web server comes handy, basically. So, yeah, it's for testing and development purposes only. No HTTPS and other fancy features, right? It's just simple and I won't say dumb, but it's just simple web server, okay? It does one thing and one thing only. It can be called from the CLI, meaning from terminal, using J web server, and then you toss some options, right? Or you can start it programmatically from your Java code using create file server. The server is created, and then you just start it, okay? We'll see both in a second. So let's go to the README file. And in the README file, we have this, yeah, this is it. So maybe I will escape this presentation mode for a second to make it easier for you to see. Please don't crash. Okay, it didn't crash. How nice. Nice of you. Okay. See, I have these in SRC main, not Java, but in resources, I have this server, and I have four HTML files and a CSS file, right? And that's basically it. And I want it to be visible or accessible via my browser, basically. So this is what I do. I go to that directory to keep things really, really simple as possible. All right, and we go here. We run this thing, and we can open it in the browser, and voila, it works. Right, and I can even click like CB and C and A again, and it's very simple server for static files, okay? Yeah. Or what we can do as well is we can go to the, I should have that in demos as well, to the server, simple server, right? And we can do something. Again, I should say like demo only, okay? Demo only. This is not how you're supposed to create like application server or anything like that. In theory, it would be possible, I guess, meaning like Turing completeness and whatnot, but let's not do that. So what we do, we create file server, listening on port 9000. It will serve stuff which is like, from the server class path. So again, the same files. It's just one thing. When the request is for the style CSS, then we read the file, then we replace the Indian red with dark blue, and then we send it as the response, like the most naive approach, like read the whole file, find and replace, and then ship that stuff, basically. All right, so this is what we do, and when we start this server, it should be listening on port 9000. Let's go to, oopsie daisy, localhost 9000. See, it's actually the same thing. Only here we have this Indian red, and here we have this dark blue or whatever because it got replaced on the fly, right? So this is not performant, it's not optimal. For sure, you don't want to have this in production. But if you just need, if you're in desperate need of like demoing something or testing something, now you can do that just using whatever comes with your JDK, right? So this is it. So either how do I say that? Programmatic, thank you. Who said programmatic? Okay. Programmatic way. I have to move here so we don't, shoot the camera. Okay, thanks. Programmatic way or from the CLI, right, as we did just here. Okay. Yeah, and this is basically it, right? So it's simple. What else shall we do? Okay, code snippets in Java API documentation. Another little change. So standard feature of Java 18 has JEP 4.13. It comes with a tag snippet. So now in a Javadoc, we can include a new snippet tag, and it's about this modern styling, right? So do you remember this tedious Control F and then scrolling the whole list in this bottom left frame for Javadoc? Yeah, now we have this Ajax search, right, since a few versions, and now snippet is going to be to make the Javadoc even more beautiful, right? So it's about modern styling. It's easy to validate in support in IDEs, as we're going to see in a minute. It's not interactive, so it's not like this, JavaScript fiddles or whatever, or Go Playground, when you just type some code in the browser or click something, or like the Swagger way. It's nothing like that, okay? It's pretty static once rendered. The code used in the snippet can be internal or external, and I will just demo that to you. I guess that would be easier. And supports not only Java syntax, so it's going to support like pretty much every syntax, right? Okay. So the snippets. I have a Javadoc sample, something like this. This is like a dumb class, doesn't do anything sophisticated. 3 files, constructor, like full constructor, and like a default constructor, like 1, 2, 3, because why not? Okay, and yeah, if you open the Javadoc, you can see the snippet here. all right? So I say that this is a doc for Javadoc sample, and this is the snippet, and this is another snippet, and here so these are like in the internal snippets, meaning they come from the inside of the Javadoc directly, and this is the snippet that comes from another file, like sample demo. So I have this sample demo here. All right, and this is like how to use my class, for example. So this is like for example, one of possible usage scenarios, right? And so this is like the external one, and this is basically it. And how to generate that? We should also have that in the README file. Yes, let me just copy that, and yeah, let's run this. Okay, and it generated the Javadoc in here, in this Javadoc directory. And how do we now browse this Javadoc? We use JWeb Server, right? Because now we have it. Right, so this is it. And this is, oopsie daisy, this is how it works. I had to refresh the page, sorry. See, and this is the Javadoc sample. And this is the first snippet you saw. And it has this nice copy button, as you can see. And this is another snippet and has this nice copy button. And this is the whole file included, right? And as you can see, it has some pieces highlighted, like this, go highlighted. And some pieces are even links to some other pages, right? So now you can see what you can do with the snippet is more than just embedding like, this code and tags in HTML, right? Or you can just use a region and say that this snippet should use a region from the external file, which is again like something like more visible, and there is a link. So yeah, how does it work? It works like this. See, we can say here that from this sample demo we are using this region, or when we go to this sample demo, then you can see that I say that this is the start of the region, this is the end of the region. Here I want to substring the substring being toString to be a link to something external, or I can highlight something, right? So I can highlight the whole regex. So this is to make the Javadoc beautiful and whatnot. If you care about your teammates, if you create documentation, and we all know that we are good people, and this is what we do, right? Every day. Okay, unless we are not, but that's another story. Okay, so let me stop the this simple web server. Back to the slides. Okay, preview features. Have you ever used a preview feature from Java? Anyone? Okay, I see 3, 4, 5, 6 people. I guess you should use them more. I mean, these are like, this is implementation of the JEP 12, so there's a concept of a preview feature that's also like well tested, and it's like verified. Still, let's say the architects of OpenJDK aren't sure if this is something what the community/industry really wants. Maybe there are some situations like some corner cases when it doesn't perform, it doesn't work as expected. Therefore, they ship it as a preview feature, which has to be directly enabled or opted in, right? So people can try it, and people can provide feedback to the Java architects/OpenJDK team. They can complain or say what's good and what not. So this is something that is subject to change, or in a different way. It might change. It's not guaranteed to change. It might change, right? And it's basically about using this -- enable preview flag. I have spoken about this at Devoxx again, so this is like another piece of video, how to do that, how to enable it, and whatnot. The most important thing is if you compile your classes using enable preview flag, right, because it's needed by the compiler, then even if in this very class there is nothing about preview features, you won't be able to use this .class file on a different JDK version without enabling these, in a different JDK version, and in the same JDK version, the people who are running this code will also have to enable preview, basically, right? So there has to be the same version of the compiler and the runtime, and it has to be opted in by for the compiler and for the runtime, basically, right? And even if it doesn't change, even if a single byte doesn't change or nothing changes, it still has to be opted in, or sorry, if, freshly compiled for the new versions. Okay, so we have a first preview feature today, pattern matching for switch, as JEP 420, and this is like the second preview, and we're going to have a third preview in Java 19, as far as I can tell. And before we start with preview matching, pattern matching for switch, nothing happened to good old switch. Both switch instruction, right, as we know it since Java was born, both switch expressions, which we know since Java 14, didn't change, right? If you have an old code, it will keep working the same way. If it doesn't, it means there's a bug, right? And you should run this as a preview feature and notify the OpenJDK team that you found a bug, basically. So this is how it should be. Okay, and this is the get greeting. And as you can see, now we are switching over an object, right? We switch over an object. It's not a primitive type, it's not an enum, it's not a string. We just switch over it, right? And what will happen if we'll run this code in Java 18? What will be printed? I'm not recruiting you, but still. Come on, don't be shy. No, not oops. Sorry? I can hear you. It will compile. It will compile, it will run, what will it print in Java 18? No, it doesn't. It doesn't depend.
Well, it does depend on the input, right? So what's the input parameter?
Okay, yeah, that's true. So let me show the whole code so that there is no cheating. So this is the whole code, okay? So this is the runtime version feature, right? And what will it print? A little reader for you. Could I do what?
Zoom it.
Okay, zoom it.
So that will print hello, this is Java 18.
Yes, who said that? Okay.
Again.
Okay, again is again. Like here, bonus is stuck. Right. It will print hello, this is Java 18. Right? Yes. So I guess this. Anyway, right. I mean, if you're curious why it's this is like the code is on GitHub, and you can run it because we have also other stuff to discuss at least now, right? So this is how it works. So pattern matching for switch instruction and switch expression can be now more null friendly, basically. Switch handles not just primitives, enums, and string. So it changed like since Java 7 or Java 14. So-called dominant cases aren't allowed by the compiler. Cases can contain guards, and sealed classes don't meet the default. If we go through every possible sealed class, like when we satisfy, let's say, the whole hierarchy, right? Pattern matching doesn't work with primitives. Okay, so it's the other way around. And switch instructions work with pattern matching too. So it's not only expression, but also instruction. And pattern matching doesn't allow fall through. And we're going to see that all in action right now. Let me just find the proper, switch pattern matching. Okay. Right, so there's a code demonstrating all of that. Let me run the code to make sure that it's like, that runs. Okay, it runs. Very nice, very nice. Right, so as you can see, the switch instruction as we know it from Java 7 remains, right? So nothing changes, and if we try to run it the old way with null, it won't work. Even IntelliJ will like complain so that it can't be null because here, see, we don't have this. In this old case, we don't have this null. Sorry, in this old switch, we don't have this case for null, so it won't work. Blah blah blah, yada yada. Nothing changes here, right? And also switch instructions since Java 14 work exactly the same. Nothing changed here. So this is the code for Java 7 and for Java 14. Like this is, you see the expression, and this is this instruction. They're using the same keyword, but this is how it is. This is how they chose it to be, right? And switch can handle now nulls, basically. So as you can see, I can have this wonderful case for null. I don't have to guard this whole switch expression or instruction with if null, do something, but please don't switch, right? Because switch used to blow using that. And now we just can have this null, basically. Yeah, and also switch expressions. And very nice feature for some people, for some use cases. It's just it can be combined with other cases, and sometimes it makes sense or might make sense to combine it with default, for example. So received null or received basically like for like default version, right? So as you can see, I have like received foobar or received null here. No, it won't, because now it works just as it was supposed to be. So like in the previous versions, like in 7 or 14, right? So like Java pre-18, I would say. So null has to be explicit. And this is just to make sure that if it worked, this would be the bug, right? That would be needed like to be reported to the OpenJDK team, basically. Yes. So as you can see, empty or null and stuff like this. Where were we here, right? And also, where is this called from? Because this is like a nested call. Come on, okay. There's something more. Yeah, about the switch. That switch can now handle the different types. So not just, as you can see, string or primitives, but it can handle, or for example, this like instant, right? So we can say, let me just close it. We can say that this is a string, this is an integer, this is long, this is a double array, right? So we can also select for double arrays or just any type of arrays, or there's something else, basically. So let me see if we have that, if we rerun this code. Yes, no, come on, where is it? You're a long, yeah, you're something else, for example, yeah, so you're an instant, right? Or you're just a string which is high, and so on and so on. And just what's the concept of the dominant case, right? So as we all know, strings, integers, longs, I mean the capital ones or the big ones are serializable, right? Therefore, I can't do something like this. I can't say first match serializable and then try matching against string, because it's impossible to like do it in this very order, basically. Because if it's like serializable and everything string is serializable, it means I just already like got into this case. So this is like, it can't be reached, right? It's inaccessible, right? Exactly. So what it will work like if we change the order, so the more specific cases come first and the dominant cases come last, basically. This is important here. If you're wondering why it doesn't work, and it says something about, does it say? Yeah, label is dominated by preceding case label serializable, basically, right? And what we can also have, right? So this is the dominant cases, right? What we also have is like this is like this is the code that used to work in Java 16, and this is the code that works in Java since Java 18. So we can have these so-called guards, right? So we're not only checking if this is a string, but also if this string has at least 3 characters, right? Therefore, as you can see here, which is you're a string at least 3 characters long, and we call that with hello, as I believe, yes, this one, and the high didn't got into that very case because high is less than 3 characters, right? Therefore, it was just high. So it said you are a string somewhere in the code, like yeah, here you're a string, basically, right? And if we try to move this below, it's a dominant case, right? Because this is more specific than this thing. Therefore, this thing is dominated by this thing. Okay? Make sense? I think it does. I mean, it's kind of like logic, right? And Again, very nice thing for the final classes. So we have this sealed classes. We have the sealed interface with 3 possible classes: final class, record, and non-sealed class. Question: why it works and I don't have to toss final or sealed or non-sealed here in line 22? Yeah, who said that? Sorry, now it's like a miss through, sorry. Yeah, but that's actually the case. Records are always final. That's why we don't have to toss final here. That's why it works, right? So when we have this, as you can see, this pattern matching, the whole inheritance tree or like the whole matching is basically exhausted. Therefore, there's no need for default unless I omit something, and then as you can see, it becomes red because I need like either cover this or toss a default then, basically, right? To make this switch exhaustive, basically to cover every possibility that can be provided to this switch, right? Right, so nothing changes here. Okay, and yeah, nothing changes here regarding the primitives. So when you have the objects, we can switch or use pattern matching with objects, but we can't switch over primitives, basically. We have this one of primitives, C, so it's either 0, 1, or like can be true or can be a character. And that's why you can see that var sometimes it's very useful because it allows more. It's not just like I'm too lazy to type the exact type, right? But still, if it was even like I don't know, like integer or character, it wouldn't work because pattern matching cannot work with primitive types, right? In switch. For that, we still have to use switch expression or switch instruction. Yeah, for the big ones, it works. For the big ones, there's no problem, as you can see. Yeah, and they can handle patterns too. Okay, yeah, so it's switch instruction. Okay, so it's not switch expression, but switch instruction, the good old one we have since the very beginning, right? So, and as you can see, now this is this fallback, right? So I have to break here, I don't have to break here, and if I forget the break here, what will happen? It says illegal fall through to a pattern. So now we're examining the last concept of this pattern matching with switch, that the fall through is not allowed. Because what it means with this pattern, what this whole pattern matching does, or what it allows us. So I'm not just, like matching this against the type, but I also alias this thing that came into this switch, right? I alias this as R, right? And it's of type of record. And then this is the scope where this R can be used. So what would it mean if the fall through was allowed, and how on earth should I be, or where from should I have the R here? Right? It doesn't make any sense to have R here. That's why the break here is required. Else, like, okay, I got matched against non-sealed class successfully. And then how can I use the R here? If it wasn't matched, if it wasn't assigned, like aliased or anything, whatever we call it. Any questions?
So if you use the same alias, it will work or not?
Let's check. R. Yeah, because it's a different scope.
Yes, but without break.
It won't, because yeah, it's not only about the name of the variable, right? It's about everything, like the, I mean, maybe I presented you in a bit oversimplistic way, but it's about the type and whatnot, right? So it's...
If you put the first type as the common parent of the next type?
You mean the sealed interface?
Well, maybe not. Well, we can try that.
Or we can even go to and try object, okay? Object. Illegal fall through. Right? Steal. And will it work if I uncomment this again? No. Exactly, because dominant cases. See, so it's pretty well guarded, I would say, and I wouldn't worry about this. I mean, I'm pretty confident once you start using it. I mean, some people don't like compiled languages because the compiler is so noisy and preventing you from work. I mean, in JavaScript or PHP, you can just SCP your code to the server and it will work, right? And in Java, you have to deal with these pesky errors and warnings and whatnot. I see it the different way. You just keep pair programming with the compiler, and when you try to do something stupid, the compiler basically like taps you on your shoulder and says, hey dude, just okay, it's not the best idea. Don't do that. Don't ship that code. Don't git push force, right, on Friday. This is what it does basically. It's your pair. It's your like your constant rubber duck or pair programmer or whatever we call it. So I'm pretty confident that the compiler does a really good job here and will prevent all of us from doing stupid things with pattern matching with switch. Any more questions? This line yellow. Switch label record R is only reachable in the whole switch. Okay, yeah, let's replace it with this enhanced switch, and let's get rid of this. And still, what does it say? Okay. No. Okay, because it's like the case label, so it won't work because we switch to the enhanced string switch, which is switch instruction, and this is the only reachable in the whole switch because it's this. We're not calling anything else, so IntelliJ is smart enough to infer that the only thing that can get into this switch is always the record. So normally it would get jittered properly, right, in production, and here IntelliJ is just trying to tell us that doesn't make sense, right? So this is why it's yellow. Okay, but who said that? I like you, I mean, no worries, we stock it. This time it was a perfect cooperation. Okay, foreign function and memory API. Who was on another deep dive yesterday when Jarek Pałka was speaking about bare metal Java? Yeah, so quite a few people. That's why I'm not going to go into super duper details perhaps, but still I'd like to get through it. So the bottom line was you can run Java you can run game engine from Java, right? That was the bottom line. Yeah, exactly. And you can run also, I mean, pretty much everything as long as it's C currently, right? So it's second incubator module, but I'm not sure if it's this. I mean, this got merged, kind of like, because previously it was like foreign function and memory was separated, and they had two other incubator releases earlier. So this is like actually like fourth release, and Java 19 is going to be again incubator module, so like fifth release. And some people are like, grumpy and come on, just ship it, right? And I would say, knowing the JNI and knowing things like optional.get, maybe it's nice that it's undergoing yet another and maybe even two more incubator modules or preview feature phases. This thing is going to stay with us for years, right? So we should rather test it before it reaches the GA stage instead of rushing and ship it, right? Okay, so it's official second incubator module, JEP 419, and what is this whole thing in Panama about, right? So it's about avoiding limitations of Java NIO byte buffer and to be safe, unlike some miscon safe, and should perform not worse than JNI and maybe even better. That's the whole point, that's the whole deal, okay? So the building blocks of this foreign memory access API. Memory segment, so it represents like memory region. Like it can be a native memory of heap, it can be an array which lives in a heap and stuff like that, basically. Memory address is just represents the address. That's pretty obvious, I'd say. Memory layout says how the segment is organized, how stuff is organized inside the segment, right? And there's also resource scope because, and this is maybe what I like the most about this API, that the whole thing is bounded when it comes to time, when it comes to scope, and when it comes to scope, like the size of the memory, and when it comes to threads, okay? And it's very, very nice for try with resources. And we can also use var handles to store and fetch stuff from these memory segments, right? Okay, so let me demo that. Let me demo that, and that should be here. Okay, yes. So, warning, this code doesn't work. Yes, and we'll get to the point why it doesn't work in just a moment, no worries, okay? It doesn't work intentionally. So maybe if I commit this, it will work, right? Okay, so it works with the same thread. So what we're doing here, right, in same thread demo, we're doing the following thing. We create a sequential layout, right? Sequential memory layout of 10 elements, and each of these elements is Java integer, right? And then we have this layout, and okay, so this is the layout, and we allocate the memory here in this memory segment. So we say allocate native, so we allocate it off heap, right? So the garbage collector will have nothing to do with that, except collecting, of course, these objects, right? But it won't mess with the native stuff, right? And then we populate this memory segment, and then we examine what's inside, what's in there. That's why we see these numbers printed here. Okay, by the way, to make this work, please make sure when you run this stuff on your own that you don't forget to add modules, right? So JDK incubator foreign here when you run it to your run configuration. I mean, this is recorded, so hello YouTube. Don't forget to like and subscribe. And smash that button, this bell button. Oh, come on, I'm not a YouTuber, I can't do that properly. Anyway, and in a POM file, we should also have this, right? So, not this POM file, the other POM file, I believe. Yes, as you can see, for the compiler, we also add the module JDK incubator foreign, right? Pretty much like enable preview, kind of like the same story, more or less. Anyway. Yeah, so we've allocated 10 Java ints outside of the heap, right? And we want to populate them, so we can populate them in, like, the simplest way of populating is, I believe, this, right? So we just go to the segment at the index, and like this is the size, and at the index we just happen to store the same value. I could store anything, right? It's just like for 0, 1, 2, I store 0, 1, 2, and so on to make this thing simple. And we can also use the var handles, and for the var handles, like we can go from memory handles and like from int layout, because sometimes you'll be given different stuff, because this could be like interop, like C could give you like some memory address or something like this. So this is for the like interoperating also with other languages. That's why it tries to be, I mean, inclusive is not the best word here, but let's say elastic or flexible, okay? So we can also set this like this. So we have this int handle based on segment or this thing. It will perform, I guess, equally well, I mean, in terms of doing the job. And then how do we examine this? We can have, as you can see, this integer array layout, and again, like this can be segment-based, or this can be var handle-based, right? And it also shows us who owns this memory segment. In this very case, it's owned by no one, and this is the exact memory address, right? And it's not owned by anyone, like no thread. And let me go here. And this is because in this same thread demo, we are we are creating that in new implicit scope, right? So it means it will work like that. For 2 threads demo, why it didn't work is this, or maybe someone wants to get some jellies. Why it didn't work? And it shows thread reader, attempted access outside owning thread.
You're defining a confined scope and this is confined to this thread, right?
Yeah, who said that? Was someone over there? Okay, great. Yes, exactly. Sorry. Yes, exactly. We are creating a confined scope, meaning the thread that creates this memory segment will be able to deal with memory segment, not any other thread, right? So this is why this basically fails. So this is, as you can see, the thread boundary, right? Obviously, I can't read this before it gets created, but when we close, okay, now it should work, right? Let's hope. Yeah, it works. Okay, right. Very nice, very nice. And now, if we close this and then try to examine this segment, even from the same thread, it will, come on, it will blow. And it blows because it's already closed, as you can see, right? So it's time boundary, right? After it's released and closed, I can't use this memory thing. And there's also one last thing, of course, which is, let's say I'm like off by one error, right? We've been there. Everyone has been there, basically. And that it should like also yell at me saying that, yeah, see, out of bound access segment on segment because there's limit to 40 and we just add offset 40, meaning you're out of the scope, basically, of this. So as you can see, it keeps me safe in terms of like the range of the memory. In time of the memory, like when the memory is already like released, I can't like even try to access it, and I can also confine it to a thread, meaning to make that off-heap memory, for example, thread safe, right? That's why it's going to be. I mean, I didn't benchmark it. I've just read the reports that this is a darn fast thing, basically, and as you can see, it's much safer than SunBiscan safe and whatnot. So this is for all of us who have this off-heap needs. This will be the new thing, I guess. Question?
So when this memory segment is allocated, does it have to be continuous? You know, because you might have some memory, but it might not be continuous.
So the question is, if I allocate this memory segment, doesn't have to be continuous? Answer is, I don't know. I would guess so, right? But it can be, you know, it's all about the addressing, right? So like it could be like, I don't know, like hidden from us and just we ask for address and it like resides somewhere else, like it, I don't know, like tape drives and stuff like this.
Yeah, but you are giving like the size of the single, let's say, cell segment, right?
Yeah.
Maybe it's possible to.
Yeah, when I'm allocating this this segment like this here, I guess it, like, I didn't check it and I don't know that. I guess it should be like consecutive, like sequential part of the memory, because memory, my friends, isn't like two-dimensional. It's not cylinder, like the DB admins say, okay? It's like a vector from here to there, right? And it's always a sequence. So this.
But you might have free memory at the beginning, let's say.
Yeah, so where is it allocated natively? I don't know, right? So it's like, of course, it's like, I guess it asks the operating system, hey, give me like the memory, and then the operating system, like, this is the chunk of memory I found it for you, basically, right? I guess if there's not enough memory, like consecutive memory, it won't work. Simple as that.
And this, about the time of delivery of this object memory, it's valid as long as the object is still alive. When this memory segment object will be garbage collected, then the memory also will be.
See, and now we're reaching the finalized story again, right? So it's auto-closable, right? This resource scope. See, it's auto-closable. Yeah, so this exactly, not when it's garbage collected. Sorry, not when it's garbage collected, right? But we are like either close it explicitly or use try with resources, and I would really recommend this approach, right? So this is the new idiom, and we also use it for Loom and something like this. Try with resources is how we deal with stuff in Java, basically.
Can explicitly memory in a new fashion. If that doesn't clean up.
So the thing is, so the comment was that we have a new way of dealing with memory, right? And there's a new fashion of dealing with memory. I mean, if there's such a need to have like off-heap memory for this, I don't know, like Apache Spark and the stuff, like systems like this, of course. But I guess like this shouldn't be used by ordinary people to, I don't know, squeeze few like promils or whatever that is, just to avoid garbage collection or something like this. I wouldn't do that, right? It's just for, and please keep in mind this also exists for interop, basically. So Java could send stuff to memory, which is consumed by another process in another technology, and vice versa, right? So this is also one of the intended usages of this. Yeah. Yeah. I mean, I didn't check it in 18, but one of the previous versions that was the case, that you can get the address from somewhere and then just try to access it, right? Yeah, and we are very close for the next thing, which is foreign linker, right? Which also relies on this native memory, not only native memory. So the intent is to replace JNI with a pure Java development model. Currently, the support is only for C on these architectures. All right. The plan is that maybe it will be extended to C++ and 86 architecture and whatnot. Right. So it's like currently there is like just C and 64 bits, but it might extend in the future. Performance should be no worse than JNI's, hopefully better. And what C-linker allows? It allows two things, so-called down calls and up calls. So down call is that you have a code written in C, and we want to call that code, right? And the other thing is, we are in Java, we want that C code to call something back in our Java code. This is the up call. So one of the scenarios that's like typical is, for example, we have a comparator in Java, right? But we have done fast sorting algorithm in C, for example. So we call the C algorithm, but we point it back to the comparator we have in Java, right? So this is one of the examples of the up calls. And I'm just going to show you a down call today. And that should be this, right? So apparently, if you want to get, or you need to get the UID, or the user ID, right? You don't have to use JNI in Java these days. I mean, if you're okay with using Panama, or you don't have to call this, forbidden by everyone method call from like Sun Microsystems, whatever, because there's also such a method. And on Linux, such a method would work. And of course, I'm the first user of this computer. That's why I'm expecting, 1,000. But you can check, for example, if you're a root, right? To check for UID 1. So this is how it works. I just want to get, I just want to get a C-linker, right? And I'm looking for this native symbol, get UID. This is basically the function call, as you can see from the man page, right? And I expect the result to return Java short. It doesn't take any parameters, right? And then I'm creating a down call handle, right? For this symbol with this functional description, and it's basically invoked here, and therefore I'm happy to present you the result, which is 1,000 in my very case, right? So as you can see, we have types here, so it's, I used var, but the IntelliJ inferred that, right? So it's safe, it's type safe, it's not some kind of like a freaking magic or follow the convention or whatever, right? And this is the way how you can call C from Java. And you may think, what's the big deal, right? Especially regarding the up calls. But think about this, that there is a certain problem when it comes to interop between languages which have garbage collection and those which don't. So for example, there's the same problem when you try to call C from Golang, right? Or make this up call. Basically, it's like this. Anytime during the lifetime of the process, the garbage collector in Java or in Golang or any other like language like this can kick in, and if it's compacting, for example, a garbage collector, it can reshuffle or reorganize the stuff in the memory. And this is a concept basically unknown in C. Once you allocate an object, it stays there, right? After malloc, it stays there until you free it, right? And this is why this upcalling is a bit more challenging, because stuff may change on the Java side, right? And still we have to like need a level of how should I say it, like decoration of wrapping, so the code from C will be able to reach that. This, even if it's not aware of such a concept that the objects may move, or the references are basically like still pointing to an object, although the object moved from one part of the memory to another part of memory. Right? That's why it's not trivial. That's why it takes so many incubator phases and whatnot. And that's why I think we should appreciate it, what they are doing for us, because as you saw yesterday, we will be able to call a really crazy stuff using this, basically. Okay. A few more small things, like now we have enhanced pseudo random number generators. So basically the purpose of this JEP, which got standard feature in Java 17, was to clean stuff a bit, to make it also easier to extend in the future and whatnot. Yeah, so a quick demo for you. Yeah, this is 17, quick demo. So we have random generators. All right, let's run the code. Let me zoom in the meantime. Yes, okay. So as you can see, I can switch, for example, now we have this random generator interface, which is since Java 17, right? And we have various implementations. So I can go for like thread random, thread local random or secure random or splittable, or the random we use many times, right? And they all like just, I say, for example, give me a random generator, right? And it's now up to the caller, dependency injection, right? Inversion and so on. So yeah, this is going in this direction. And also we can check what random generators we have available in our system or in our JVM, basically by using service loader mechanism, which came, I believe, with Project Jigsaw. So basically for every possible implementation of random generator, which is like service loader, or available for service loader, let me put it that way, we can, as we can see, no build, debug, we can say that this is like the random number generated by, and we have the canonical type of this random generator. And this was like one of the changes was also, I mean, maybe it wasn't for that, but what it allowed, it's like we have, it's now easier to implement new pseudo-random generators in Java. Should you have like, I don't know, any need for any specific random number generator because you're doing, I don't know, some research, or you work at a nuclear plant, or whatever the reason might be. They also clean the code internally, and that's basically the stuff, right? So we have like a new random generator interface. There's a new standard feature since Java 15. Who had ever used strict FP? What does it do? What did it do? Because it's no more. Okay, it exists, but it has no effect. Sorry, could you repeat? Define platforms. I would still like say it's okay. It was, as I remember back then, it was the difference because the CPUs had different registry sizes. So like Intel CPUs had registries for, 64-bit longs, and the ADM released CPUs with 80-bit registries. So when you're performing a float calculation, you could get different result on different CPUs, right? That's why in Java we had strict FP, meaning even on AMD we got the same results as if it was 64-bit result registry. and I'm just doing that from my memory, which is like subject to fail me and trick me, but this was about it, right? And now since we have like sophisticated set of CPU instructions and whatnot, there's no need for strict FP anymore. That's why it's basically a no-op. Like now all CPUs are guaranteed to provide, since Java 17, the same floating point operations results, okay? Again, like another change that was discovered, like how Java was used in the combat. So we have a concept since Java 9, I believe, or I might be wrong, that there's like deserialization filters, right? So deserialization was one of the mechanisms that made if we were deserializing stuff given by someone out there, there was the risk that we will deserialize something nasty that will corrupt our process, operating system, memory, you name it, right? So there was a concept, and it's called deserialization filters, but these filters were global up to now. And here, since Java 17, we can fine-tune these deserialization streams, for example, right? So if you're deserializing stuff from an external system, or I don't know, nobody knows where from or who from, you can just turn it on and or tune them per specific deserialization stream. For Apple users, that might be important. So there is a change. New Macs are rendering stuff not using OpenGL, but this is called like Metal or something, right? So now Java is like ready for that when Apple decides one day that a new Mac will no longer support this OpenGL rendering pipeline. It will still run because it will switch to the Metal one, right? By default, or like under the hood, so to say. And of course, we have ARC64 port. From various little stuff, what we have string deduplication for ZGC, parallel GC, and serial GC, which wasn't the thing previously. And G1 heap regions can be up to 0.5 gigabyte now, which I think is cool. Some stuff that got deprecated. So Applet API got deprecated for removal, right? So it's no longer just deprecated, it's deprecated for removal, and one of the future Java releases might come without Applet API. Who's been using applets over the last 10 years? No way, there are 4 people. What were you using applets for? Okay, last 5 years. No one, okay, case closed. But still, what were you using applets for?
I was using some application which was exchanging the data between UI and backend.
Okay, so data exchange between UI and backend, for example, ladies and gents. Okay, and because Applet API got deprecated for removal, this is one of the reasons why Security Manager also got deprecated for removal, and by some, this is very controversial change, right? Some say that they're going to miss Security Manager a lot. Who was using Security Manager? Yeah, you were using applets, that's obvious. Anybody else? Yeah, exactly, that's the reason. This is what they say, right, at OpenJDK. And that the Security Manager was a thing of its time, or an attempt to be a thing of its time. But since things changed over the last 20 years, that we have different challenges, then we have different threats, security threats and whatnot, there is no more reason to maintain Security Manager because it's pretty dumb thing when it comes to maintenance. Right? It's scattered through many files in Java source code. It's difficult to maintain, and they even quote the numbers that it wasn't. It even theoretically couldn't prevent the majority of the attacks against, for example, Java process or something like this, right? So maybe there will be some mechanism, I don't know, for sanitizing where can you load classes from or something like this, but this will be something different. This is not part of the JEP deprecating the Security Manager. Also, the now setting custom socket implementation factory is deprecated, and some stuff got removed. So RMI activation got removed after being deprecated for removal, and experimental AOT and JIT compiler also got removed. And since we didn't do a break, I think this is like a more or less time to conclude this presentation. So my honest request for you is to always, and for every speaker, not just me, and not just at Devoxx, to provide your feedback, right? Because then organizers know and we know what was okay, what wasn't okay. Since we see each other, you can pass me the feedback in any form, including like a paper form, but I would prefer if you use the Devoxx app, okay? And if you can't or don't want to use Devoxx app because whatever reason, please go to this. I mean, this is a very simple form, and I don't know who you are. From my point of view, you are anonymous, right? And even if you're watching this on YouTube later, I don't know what time that is, please also go and fill this form so I know how did you like the presentation or didn't, or what was okay, what wasn't. Thank you very much for taking the picture. Thank you very much for your submissions. And please do that for every speaker, all right? Not just me. Okay, I guess this is the end. I hope I shown to you that Java 17 and 18 are really worth switching to. This is the code. Dziękuję bardzo. Thank you very much, and this is the link to the slides. Should you be around, I'll be also around if you have any questions, and if you'd like to learn something about Go tomorrow, I'll be having a talk tomorrow in the room 2 at 9 a.m. First thing in the morning, right after the party. Sorry.